Let us see another example. We are moving now to the next one. We have seen when the surfaces are free. We have seen when we have a string. Now let us see when we have some friction. A uniform load, the moment we hear uniform load, it means that weight is going to occur in the middle of, is going to act in the middle of that rod. Half of mass 14 kilograms and 5 meters long, resting in equilibrium at an angle of 30 degrees to the horizontal, with its upper end resting on a smooth vertical wall. The word smooth means we are not going to have any friction. And lower end resting on a rough horizontal surface, full stop. Find the reaction at A and B, then the coefficient of friction. So start by sketching, of course. So in our solution, anything in these diagrams, you start by putting a sketch. So this is going to be, now this is going to be my vertical wall. I'm going to have my horizontal wall here. Okay, you are getting me that now. It's resting in equilibrium at an angle with the upper end A resting on a smooth vertical wall. So it's resting here on a smooth vertical wall. So because it's smooth, we don't have anything like friction. This wall, but now because there is contact, this is going to be our A, this is going to be our B. Here there is contact. The moment we start to have contact, there is reaction. So we put reaction perpendicular to that. So this is our reaction at A. Even here there is contact. Once there is contact, whether smooth or rough, there is always a reaction. So we have reaction here. This is our reaction at B. Okay, this wall here is smooth, but the surface here is going to be rough. Now, because it's rough, when this one is trying to slide, it's going to go in that direction, first of all. Then to this friction is going to act in this direction. So this is going to be our friction force. Now, from here up to here, I think that this one is 5 meters long. And then, because it's uniform, its weight is going to act here in the middle. So our weight is going to act there. But what is our weight? We shall get the mass times B, the gravity. So this is going to be 14 times B. Now, this one is in equilibrium, but it has an angle of 32 down horizontal. As simple as that. These ones are very easy once you can put the information. Of course, because this is vertical and this is horizontal, this is going to be perpendicular to that. Now, we have finished summarize the question. Remember our coefficient of friction here is going to be RB of this. Now, so it means we have to get this, the one also that, then after we shall get that. Now, say here, once you reach this step, you start resolving. So, you start with this, there is no any force, so you can't resolve this. So you have this and this. So, first of all, I resolve vertically. Remember, this one is in the equilibrium. It means that the upward forces are going to be equal to the downward forces. So, from there, my RB is going to be equal to the downward force, like that. But you know our B is 9.8. So you put 9.8, so it is going to be, now this is going to be the newtons, which will be 137.2, and these are going to be newtons. And you have got your reaction at B. As simple as that. You see? Now, we come now to this force here. So now we are going to resolve these ones horizontally. So they resolve this horizontally. It means that now, you see this one is going this side, and this one is coming to this side. So meaning, horizontally, I have this as, I'm going to get that as R. This one is going to be RA. It's going to be equal to this one coming this side. It's going to be F. And I call this equation 1. Now I have two unknowns. I have this and then I have that. Now the question is, we are going to take moments at the scale of 1. Now, I I have this point and I have this. The question is, where can I take moments from so that I can eliminate one? The question is very easy. Look at these 2 points, A and B. Now, where do you have many forces? So here you have 2 forces, here you have 1 force. So you take moments now here. Okay, so you're going to take now moments there. Why? Because here you have 2 forces and here you have 1. So we take here where we have the many forces. So now I'm going to take now moments at at B. Sorry, moments at B. Why at B? For the reason you know now. Because B has more forces. So if I take moments at B, let me take them anti-clockwise. So if I take them anti-clockwise, now you see first of all, from B here, this force is going to be, its perpendicular distance is 0, and then this one also is perpendicular distance is 0. Why? Because when you are here, you don't have anything like perpendicular distance. Remember, moment is equaling to the force times the perpendicular distance. So when I'm here, it's that first of all, okay, let me get to and I show you how these moments are going to be moving. Okay, I think you see we are taking moments at B. Now you see that this force is coming from here. So here it doesn't, you see the direction in which it is. So you see this is the force. The perpendicular distance from here is 0. That's why we are going to say now, first of all, F times 0, then plus. We come to this one, you see RB, this is RB. But from this point, there is no perpendicular distance. So that's why I also say now, RB times 0. Okay, so we are done with this, we are done with this. Now these are the forces, so that's why here we are going to have only zeros. Because there is no perpendicular distance. Now we have this one here. So this force I think you can see, for it is going to be clockwise. And when we come to this here, this force here, you see it's going to be anti-clockwise. So I'm going to add plus 14G times. The question is, what is its perpendicular distance? Now its perpendicular distance, because this is, now allow me to draw this sketch here. From there, and then I draw this one here. This is our 30 degrees. Remember, if this is in the middle, this is going to be 2.5 meters. This one is going to be 2.5 meters. So meaning, this is 2.5 meters. So if I need this length, it means this is going to be adjacent and this is opposite. So this will be 2.5 cos 30 meters. This will be 2.5 cos, sine 30 meters. So now I have if I want this force, you see this force, the perpendicular distance from here up to here is this. I'm going to get this force, but you see it's acting anti-clockwise. I think you can see from here, anti-clockwise. The perpendicular distance from here up to here is going to be this. So 2.5 cos 30 is going to be equal to the clockwise. The clockwise, I think you see, this one is the first is going to act clockwise. Now the question is, from here up to here, what is going to be our distance? From here up to here, you need the perpendicular distance. I think it's going to be the same there. So this is our force. So from here up to here, I need that distance. So we're going to use the same triangle, but down, this one is going to be for the big one. Remember now, this is 5 meters, and because I need this distance, this is still 30. So this one is going to be for 5 cos 30 meters, and this is going to be 5 sin 30 meters. As simple as that. So now I need this opposite. That's why I'm adding now that. So I'm going to say RA times now. This is the height here. It's going to be now 5 sin 30 meters. So 5 sin 30. So this is going to be 0. We have this. So this is going to be 14D times 2.5 times root 3 over 2 equal to RA times 5 times 1/2. Okay, from there, we can aggregate our RA as get our calculator, and then we place that. So here I'm getting 187 newtons. This is my RA. And from here comes that our RA. But our RA is equal to F, implying that our F is also going to be 118.8187 newtons. So we have the reaction at A, we have also reaction at B. You see, it was easy because we took the moment where we have many forces. That's why it's easy. Now, if we have F, remember the one the coefficient of friction. So this was part A. Then our part B, know that always our friction is equal to mu because it was here. So we are going to get this friction times now the reaction there, RB. As simple as that. So we have this, we need this. So our friction here is 187 equal to mu into our RB, which is 137.2. Implying that our mu is going to be, get this, we divide it here, 0.8187 over 137.2. Now our mu, this is the coefficient of friction. So it's going to give me 0.8660. That's going to be my leaving this for the small braces. As simple as that. So, as simple as that, now we are done with that question. So, that's it. That's the case when you have friction. Whenever you have friction, this friction is acting here. Remember, friction is given by the coefficient of friction, then times the reaction. But reaction here is RB. That's why this one is F mu RB. But we have this, we have also RB, then we can easily get our reaction. So, that's it. I wish you well.